right? Um, just a little bit more time. So 8:05. Yeah, so just to repeat for all the stakeholders that have joined us, our students are going to be giving their speeches in order. And after each speech, there'll be a little bit of time for about like 1 to 3 questions. So if you come up with any interesting questions that you'd like to ask about our students' projects, if you think like there's something more you want to learn about, or you want to maybe challenge them a little bit, always encourage to ask some questions, kind of to cultivate that environment of and discussion as well. Okay, so it's 8:05. We will get started. So I'll introduce our first student of today. So first up, we have Jennifer, who is a rising senior who took on a project that combined hardware, networking, and lots of live data. Um, while the start of her school year cuts her time short before her ability to work on milestone 3, she still made huge strides and demonstrated great skill in bringing together multiple different systems into a single project. Um, so without further ado, we'll have Jennifer give us a demo of her project.
So, my name is Jennifer. I go to Granada Hills Charter High School, and like Daniel said, I'm a rising senior. And the project I picked was the ESP32 weather station, which basically uses an ESP32 and it gets the temperature and description of the city around me and displays it onto the OLED. So, unfortunately, my device, like the two ESP32s, won't connect, but I do have a video of it working. So I'm just gonna screen share that. Okay. So right here, you see the temperature, the description, the humidity, and the light displayed onto the OLED. And if you look at the humidity, you can see it increasing. And this is because I was holding the thermistor, which increased the humidity. And then right here, I turned off the light. And if you look at the light, which is the fourth line, you can see that it turned dark, because I was using a photoresistor. And then when I turned the light back on, the light intensity turned to bright. And let me try to use my camera. So right here, I have my ESP32 sender. And then right here, I have my ESP32 receiver. So there's no wires connected. So they're connected through a Wi-Fi channel. And this is my thermistor, which gathers the humidity. And on my breadboard right here, that's a photoresistor, which gathers the light intensity. And one of the main challenges that I faced during this was definitely trying to get the two ESP32s connected, because at first I didn't realize that in order for it to connect, the two ESP32s had to be on the same Wi-Fi channel as the mobile hotspot. So when I figured that out, I was able to write some code that got the Wi-Fi channel from the mobile hotspot, and so the and set it to the Wi-Fi channel for the two ESP32s. And I wanted to join Blue Stamp Engineering mainly because I wanted to make cool projects with the help of others, especially because using an ESP32, I've never done it before, and also because I also really want to work on my coding, especially because I've had experience in Arduino IDE in the past, so I know a little bit of hardware. So I just want to focus on my coding, and that's it.
All right, thank you so much, Jennifer. We're open for any questions from either the students, other instructors, or the parents as well. I know my students have been preparing some questions. Do you guys have any questions to ask?
Yeah, I have a question. So what
Yeah,
was like
go ahead.
what was your alternative to like the ESP32s not connecting?
So yeah. That's a great question. So, like I said, since the two ESP32s, they couldn't connect, and well, even when they do connect, it's very inconsistent. So you don't really know when the ESP32s are connect. For example, like right now, my ESP32s couldn't connect, so I couldn't show you like a live demonstration of my project. So even after BlueSAM ends, I hope to still work on this project, and I hope to use a MQTT like web server instead, which is way more stable. So it gets the data from the sensors and then it uploads it to a web server. And then my ESP32 receiver gathers that data from the web server and then displays it onto the OLED.
Cool. Any more questions?
Yeah, I have a question. Um, of the skills that you learned while you were working on this project, which one is your favorite, and what would you like to use the skills in general for going forward?
Yeah, so the skill that was my favorite that I learned throughout BlueStem engineering, I guess it's not really like about the coding, it's not really about the like the hardware, but it's rather just being persistent and being persevering, especially because, like Daniel said, my school started, so I really didn't have a lot of time to go to innovation hours, and I only was able to attend 30 minutes out of like the 3 hours of class that we had. And so a lot of the things I did was really independent, and so I couldn't get a lot of help with it. So definitely the skill is persevering through the challenges, even when you don't receive help.
Awesome.
All right, we have time for one last question.
I have a question. Yeah. I've actually never heard of an ESP32. For what I've heard from your presentation, it seems to be some sort of camera, but could you explain like what it specializes in?
Yeah, so an ESP32, it's actually not a camera.
Oh
It's
man.
a
Okay.
yeah, it's a microcontroller. Sorry, so no camera. So it's a microcontroller, so it has Wi-Fi and Bluetooth, which is why I was talking about how you can like wirelessly connect the two ESP32s. And so I actually connected the two sensors to it, the thermistor and the photoresistor. And yeah, the microcontroller basically like gets that data and makes it readable and then displays that onto the OLED. So it's not a camera.
All right, thank you very much, Jennifer. Those are some great answers, and thank everybody for the questions. So let's have Julia introduce our next student.
All right, so our next student will be next. He did the International Space Station project, exploring various, exploring and tracking the International Space Station first on a Pi portal and then on a Raspberry Pi. He implemented various modifications, including a predictive track and showing nearby cities. And so I'll turn it over to Next to tell you more about it.
All right. Are you guys able to hear me?
Yep.
Okay. So hi, my name is Nex, and I'm a rising senior from Portola High School in California, and I'm super excited to show you all my project today. So to introduce this project, I made an International Space Station tracker with the Raspberry Pi Model 4 and a 7-inch LCD display screen. So the the base project had a red circle, which shows the current location of the ISS, and a yellow line that displays the path that it took. And you guys can see it on my other screen here on my Nexus iPhone account. You guys can see the device at work. And then, so that was a base project. And the first modification I made was the green prediction trail. And this trail basically shows the predicted path of the International Space Station. And then my second modification was in the bottom left. It shows the time, the nearest city to the International Space Station, and the distance to it. So that's kind of my project and what it's supposed to display. So the most challenging part of this process was definitely in my first modification. I had some difficulty calculating and transforming the prediction coordinates. So when I was trying to calculate the latitude, longitude for the predicted path of the space station, I had some trouble with that. Some of the libraries I used weren't inputting correctly. And actually, the base project used the Adafruit Pi portal, which is a different device. However, that device could not handle some of the Python libraries I needed to use. So I made the decision to switch from the Pi portal to the Raspberry Pi, which is a more powerful computer. And then ultimately, I was able to get it to work. So the challenge was definitely, it definitely took the longest, but ultimately it was the most rewarding because it was really nice to see all my hard work finally show up on the screen. And that kind of leads into my biggest takeaway, which is to be open-minded. It's very easy to get stuck and repeatedly try to do the same thing over and over again. And it's important to know when it's time to try a new approach. For example, for me, I wasn't able to import some of the libraries into the Pi portal, so I switched from the Pi portal to the Raspberry Pi. And also when I was writing the code for the Raspberry Pi, I had to switch from the original PyPortal code to a new library called Pygame. So that's some of the examples I had of that mindset, and that's also it applies to all facets of life. It's a really useful mindset to have, not just in engineering, but just in life in general. Yeah. And then I chose Bluestamp personally to gain more experience with engineering, and specifically my project because I'm interested in space. So it was nice to have both engineering and space combined together in one project. And I really enjoyed my time here. I learned a lot of new information and gained valuable practical experience in engineering. And overall, I was very satisfied, but I'm also hungry for more. I feel motivated and ready to create new and exciting projects in the future. And thank you for listening. And does anyone have any questions?
I have a
I
question.
have a
Yes,
question.
Dave.
I have a question.
Yeah.
So,
Well, go ahead. You go ahead.
so after this program, after this weekends, are you gonna like add more to your project? And if so, what would you add?
Yeah, I was thinking to start for sure, I'm gonna add some more satellites or more like astral objects, for example, like maybe Chinese satellites or like other country satellites. And then in the future, I might try to import it onto like a different or onto my like regular computer instead of Raspberry Pi. Make some like more like advanced changes to it.
Yeah. So I'm interested in how you predicted its path, which is cool. I see
Mhm.
it on the screen. I can see it moving. Um, are you are you running that calculation yourself, or are you pulling that information down from the web somewhere?
So I'm using an algorithm called the SGP. So that's an algorithm with, or actually, it takes information from another or from a data source called a TLE data. So it's basically two lines of numbers, and then those like represents information about an object orbiting the Earth, for example, the ISS. So I
Mhm.
took the ISS's TLE data, and then I used the SGP algorithm. It's also a library on Python, but it's just
Mhm.
an algorithm that can give you information based off of the TLE data.
Okay,
And
so
then
you're running that calculation locally. You're not. It's not like NASA's telling you where the ISS is about to be, and you're just displaying it.
right. I'm doing the calculate or I found the XYZ coordinates and I have to
Yeah.
convert it to latitude, longitude, and then
Yeah. Awesome. Nice.
All right, and I think we have time for about one more question if anyone has anything. All right. Well, if not, then great job next, and I'll turn it back over to Daniel for our next presenter.
Yeah, sounds good. So next up we have Vishal. So Vishal is also another rising senior who came in with little experience in circuitry or robotics, but that did not slow him down one bit. He's built a ball tracking robot from the ground up, learning to integrate sensors, motors, and computer vision into a fully working system. He's asked very thoughtful questions every step of the way, and by the end, he's not only completed his robot, but also demonstrated a clear mastery of the key concepts behind it. His progress has really shown what happens when curiosity meets persistence. So without further ado, let's have Vishal show us his project.
Can you guys see the screen?
Yep.
Okay, so hi, I'm Vishal, and the project I made at Bootstrap Engineering was the ball tracking robot. So it essentially works by combining a Raspberry Pi camera with motor controls in order to follow a red ball. I chose this project in BSc because I wanted to learn how to connect computer vision with physical robotics, and I also thought that this ball might one day like help me to solve real world navigation problems. So the first step is to control the motors. I use the GPI zero library to make it easier to move the robot forward and backward and turn. So as you can see, here's an example of the code where I define the motors. So next I connected the Raspberry Pi camera using the Pi Camera 2 library, which lets me capture live video frames that my code can process in real time. So once I have the frames, I need to detect the red ball, right? So I use OpenCV in order to convert the image from RGB to HSV color space because it's easier to filter the color pixels. This is important because HSV makes it easier to separate colors even in changing light conditions. So this function then defines the largest red object in the frame, fits a circle around it, and then gives me two things, the radius and the X position. So before tracking, I need to calibrate the camera in order to find the focal length using a known ball size and distance. So now the robot can react. So essentially what should happen is if the ball is centered, it should move forward. If it's off center, it should turn toward it. If it's very close, it should stop. And if it's lost, it should like turn in the last known direction. I'll show you a video. Can you see the video?
Yes.
So as you can see, when I move my foot with the ball, it tracks. So So you can see I set the code so that if it's like around 4 inches or less, if the robot is around 4 inches or less to the ball, then it should stop automatically. So some challenges that I faced were the lighting conditions. So even after I implemented the HSV ranges, sorry. Even after I implemented the HSV ranges, the ball kept tracking other objects in my room, probably because they were also red. So I had to get them out of the way and fine tune the HSV ranges even more so that it would only detect the red ball. Another issue I found was that the ball was overshooting too much, which led it to prioritize moving left and right rather than moving towards the ball. And another issue that I had was yesterday and today was when I finally got the ball tracking aspect of the robot to work. However, sometimes what would appear in the console was that the ball was supposed to turn left or right, but it wouldn't actually do that. And this was because I accidentally set the function for the turning function to be at such a slow speed that the robot cannot keep up. So I joined the BSc program because I wanted a more hands-on experience in engineering beyond what I could get in school. So I've always been interested in aerospace and robotics, and I saw this chance to explore robotics in like this focused environment. So this project showed me how engineering is not just hardware and software, it's also about creativity, problem solving, and patience just to make something functional from an idea. Okay, so thank you all for listening.
All right, that was a great talk. Are there any questions for Vishal?
Yeah, I had a question.
Let's go.
Okay. So you said that this can apply to like stuff in the future, right? So what does this or like what are some real world examples of this technology?
Uh, some real world examples of technology could include self-driving cars. This technology is also found in drones, assistive devices, and search and rescue robots, especially in the seas and stuff.
Awesome.
Are there any other questions for Shaw?
I have a question. My question is, um, if you had more time to work on this project, what other modifications would you want to do?
I would probably add ultrasonic sensors because I was with the amount of time I was given, I wasn't able to properly implement the ultrasonic sensors. So I feel like that would have been a lot helpful because I had to keep moving things in and out of my room a lot. So the ultrasonic sensors would have just helped the robot to deter away from these objects rather than just like ram through them. And I also would have implemented probably like shape detection.
Awesome. I think we have time for one last question. If not, we can move on to our next student. All right. Okay. So we'll move on to our next student then. So for our next student will be Ria. So Ria is one of our youngest students, but you would not be able to tell that with how well she was able to kind of accomplish her project. So came in with a little bit of coding experience, but this summer she really dove headfirst into programming in C++ with Arduino. Her project was the third eye for the blind, creating a wearable device using ultrasonic sensors. Um, Furthermore, she picked up these coding concepts really quickly on the fly and debugged her way through tricky hardware challenges and turned that idea into a functional prototype. It was really inspiring to see how quickly she adapted and how determined she was to get everything working. So, without further ado, Ria, please take it away.
Hi, my name is Ria, and I go to the Edgemont Junior Senior High School, and I'm going to eighth grade, and my project is the third eye for the blind. And I chose this project because it seemed like it would be a good project to get me started with Arduino, and I thought I would be able to learn and understand how to make circuits using breadboards. And my project helps visually impaired people identify obstacles in front of them. And my project uses an ultrasonic sensor to detect objects in front of the person, and it includes a passive buzzer, which alerts the person if there's an obstacle in front of them. Um, and this is my project. I attached it to a glove so it can be easier to use. So this is the ultrasonic sensor, this is my breadboard, and this is the battery. Um, so so if I put my hand in front of the ultrasonic sensor, the buzzer goes off. Um, and it plays like different tones, like based on how far away the obstacle is from the ultrasonic sensor. And I also added a GPS module to get GPS data, which can determine where the user, like where the user is. So, it the GPS module tr it 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 logs the information in the Arduino IDE. I'm gonna share my screen to show. So um the this is the serial monitor, and it logs all the information in the serial monitor. So this is the latitude, the longitude, and this is like the date and like the year and stuff. So you're able to like log the data of where you are. Um, and so I put everything onto a glove, and yeah, and so one problem that I faced was that I didn't understand the language because I had only done like Java and like Python. So I wasn't very familiar with coding in the Arduino IDE. So I had to learn how to do that, but I figured it out. And I also struggled with one of my modifications, which was putting everything onto a glove. Um, because there was like all these parts, which included the ultrasonic sensor, the GPS device, and the battery. And I overcame this by using the bottoms of the other gloves that I was sent to me to extend the glove to my arms so I could fit all the components. And I joined Bluestamp because I've never done a lot of programming, because I've done a lot of programming with languages like Python and Java, but I'd never done anything that included hardware or robotics. So, like for the past couple of years, my main focus has been like the software, but I haven't really focused on hardware and stuff. So I think this is like a really good program to help me get started with. So I was exposed to like a lot of hardware. And I also wanted to learn how to make projects that have an impact on people and make their day-to-day life easier. And I got a lot of experience doing this, and I really enjoyed it. And I learned how to wire a circuit, and I learned more about ultrasonic sensors and more about the Arduino Nano. And I also learned about the GPS device, which I had never even heard of before. And I learned how to wire the circuits by myself, and I also knew where each component should go. So that was really cool. So yeah, that's my project. Thank you for listening.
Great. Thank you, Ria, for that amazing presentation. Are there any questions for Ria?
I have a question. Yeah. So, yeah, obviously the your project is like it's supposed to help blind people like sort of like see, right? But yeah, I was you said I would like to hear you like explain how you would use it and in what situations would it be used. Yeah.
I think it would be used when they were like walking like just like around like on the street or something, and there are like a lot of people there, so they can like detect obstacles in front of them. And so that's how the passive buzzer works. But I think instead of the passive buzzer, I would replace it with a vibration motor. So it's like less annoying in public, but they can still know um like if there's an obstacle in front of them. So yeah, they would like use it in public, like if they're like walking or like maybe if they're taking a walk and there's like something in front of them, so they not like walk into it. Yeah.
I have a question. So I think it's really cool that you kind of put it all in the glove, so it makes it easy to wear and use when you're, walking around, as you said. Do you have any ideas for other areas or like other wearable ways that it would be useful?
Um, I think it would be useful, like maybe like on like a hat, maybe, or maybe we can make it like a smaller version, like less like, you know, like with all this stuff, like it can be really annoying and maybe not as efficient. So maybe like a much smaller version that maybe you could put in like a shirt, maybe.
Cool.
We have time for one last question. If not, we'll have Julia introduce our next student.
All right, so next up will be Isaac. So he did the thermal camera project, and then initially the thermal camera project was fairly simple, connecting a sensor and getting output in the terminal. But Isaac took it much further with modifications, including building a heat map that more accurately displays temperature in a more user-friendly way, having some X11 forwarding so that he's able to go back, be able to see things from his Raspberry Pi on his computer, and then also implementing some heat thresholds, a buzzer, center pixel, and other awesome modifications. And I will turn it over to him to tell you more about those.
Uh, yeah, I'm gonna start now. Okay, so yeah, hi, my name is Isaac. I'm a senior. I'm a rising senior at Lindbergh High School, and I'm very thrilled to share my project from Bluestamp and what I've been developing over the past 3 weeks on my thermal camera project. So in my hand now is the complete thermal camera system. There's two main components. There's the sensor itself and the Raspberry Pi microcomputer. So quickly, how this works is the sensor will collect temperature data from infrared radiation and transfers that data all the way to my Raspberry Pi. And the Raspberry Pi is powerful enough to compile that data and create and using programs from my laptop, I'm able to use the data from the Raspberry Pi and display on on my monitor. So, um, yeah, when it's fully functional, it should work very well. And I'll share my screen. It looks like this. Right now, the sensor which is in my hand is directed towards me, and you can see a rough outline of my upper body. And yeah, there's a few other features that I could explain later. But yeah, there's but firstly, I'd like to explain the main objective. My main objective was, integrate this sensor with the microcomputer and, understand really how these two connect and how the steps they take to communicate with each other. And also with that, I could this actually display it on a screen as big as my monitor instead of just, like a handheld screen. And in addition to being able to display on my monitor, I can also add widgets and buttons, and to improve user interface and modifications where could be made such as if you notice there on the right there was like a color bar like a display which indicated which color corresponds to which temperature. I also added like the display on the the temperature display on the center pixel at all times, and yeah, buttons to like take a picture, and also this feature if it's hot enough, it will play a warning sound. So, but like most of this like did not come without challenges, and there's nothing more frustrating than trying all the solutions that you can think of and being met with the same errors over and over again. So, and this was found in components like my SSH server, Circuit Python, which is a programming language I was using, and sometimes the temperature readings were delayed or completely failed due to like poor latency issues and stuff like that. But no, these errors are what Bluestamp is all about. I joined Bluestamp for direct hands-on experience, to express my interest in electrical engineering and, exposure to these types of errors because as time passed, I got exposed to more and more of these errors. And from there, I became more motivated to, find solutions and and eventually, yeah, I did find these solutions, and sometimes I understood exactly what the solutions were saying, how it worked. Sometimes I didn't. I had no idea how the solutions worked, and it just seemed like a magical fix. But whether I understood the solutions or not, it didn't matter to me because in the end I found a fix to my problems, and I could deal with those complications if I ever encountered them in the future. And for why I specifically chose this thermal camera project, it's because I was very intrigued by its intricate hardware and software integration, how these two parts connect to create a functional device like the thermal camera, and also because of data visualization, because temperature measurements by itself only exist in the form of numbers. But now with this thermal camera, I can actually visualize them in the form of heat maps. And yeah, that's pretty much that. With all that being said, that is the end of my presentation. And yeah.
Awesome job, Isaac. And does anyone have any questions for him?
I have a question. So what was your like favorite aspect to your project?
Favorite aspect, probably, I don't know. I don't, maybe this doesn't have anything to do with like, well, it does, but probably just like connecting the circuits all together. It was just I just found it so fun, just like how the I could go from like jumper wires to the Raspberry Pi and then connect that, and through that I could connect it with a USB into my laptop and another one to my monitor, and then after all of that I compile everything together, it all works perfectly. So I think, yeah, connecting the circuits was my favorite aspect.
All right.
I have a question.
Yeah, go ahead.
Um, so in what situation would you like use this device? Like,
So,
do
go on,
you
go on.
have like a certain category of people that you're thinking of, like you're trying to help, or?
Well, right now, this unfortunately, like this is it's like my setup is like basically cemented into my like on my desk, but it once if I ever get like a poor or if this ever like becomes portable, I think I could have like actually like serious considerations about like like leakage detection in buildings, or like in like industry maintenance, or even I heard like maybe police use this in like search and rescue operations when they're trying to find a specific like per person or missing personnel, or objects that are of concern. And also uh um it can also be used in uh a while sorry surveillance, security cameras and thermal cameras. Those are two, and those two are like closely related.
Awesome. And then I think we have time for one last question. All right. Well, if no one has anything, I'll turn it back over to Daniel. And great job, Isaac.
All right. So next up, we have Charles. So Charles here started off with relatively little coding experience, but you'd also never be able to tell it by looking at what he's accomplished so far. Over the course of the program, he's not only learned how to code, but also developed a strong independent workflow. So he's figured out when to keep pushing for a solution on his own, and also when to swap over and ask for guidance, striking a very key balance that's very important for any engineer, any future engineer. He is an engineer. His final work was a suite of text-based tools, things such as image to text, speech to text, and text to speech programs. And the way that he's pieced all these different technologies together into something cohesive was really quite impressive. So without further ado, let's have Charles show off his project.
Hi, I'm Charles, and I'm a rising junior at Roslyn High School. My project is the optical character recognition using the Raspberry Pi. So it uses a Raspberry Pi 4, which is basically in this case, and a camera. But I also added a speaker for text to speech, as well as a microphone for speech to text. Um, so what it does is basically it recognizes characters through a saved image taken by my camera. Uh, so I'll share my screen to show you what that looks like. All right, is my screen visible?
Yep.
All right, so yeah, when I run this code, um, what it does is it recognizes text through the camera, and it also uses like different processing ways, I guess. So it uses like threshold. It kind of separates it like the foreground from the background, but in this case, it also uses like canny, which just outlines the text. So yeah, I also implemented the speech to text using the microphone, which I didn't actually use with the camera, but I implemented like translation and other things, which was pretty cool. I will demonstrate that right now. So once this runs, it just recognizes speech through the through the microphone. I made it so that it could translate to Korean. So yeah, it's basically my speech to text. So a problem I faced while with my optical character recognition was trying to take better pictures with my Raspberry Pi, because sometimes it did pick up like characters, but other times it didn't. So what I ended up doing was getting another camera, which was a bit better, but it was still a bit inconsistent with the way it was recognizing characters. Another problem I did face was with the speaker, since it was on extremely low volume, and I didn't really find a way to fix it, but yeah, I was trying to do that. Yeah. A lesson I learned on the way was basically to use resources online instead of relying on others as much. So yeah, I believe like problem solving independently was better before asking for help. I chose Bootstrap because of my interest in engineering as a way to improve society. I believe creativity and technology can enhance people's lives, and this kind of inspired me to explore ways that engineering can benefit others. And my motivation for my optical character recognition was to kind of explore how machine learning can assist people with visual impairment while also challenging myself to take on a more software focused project, since that was kind of where I was lacking. So yeah, thank you.
All right. Thank you so much, Charles, for that amazing presentation. Are there any questions for Charles?
I have a question.
Yeah.
So, for the text or the image recognition, I believe for that, how does it work? Is it like AI? Is it like a certain like library, or like can you
Yeah,
explain
I
like more on that?
downloaded like a library, so I guess that kind of was like machine learning because they had to make the library to kind of recognize the text. So yeah, the library I did download, I believe, was PyTesseract. So yeah, that was kind of the part for my optical character recognition.
Any other questions?
Yeah, I have a question.
Yeah.
Can your like character recognition like recognize text that are like different colors or different fonts?
So for fonts, I only tested that with like the older camera, but it was kind of ineffective because it wasn't able to kind of recognize that character. But with the new camera, I believe it's much more like efficient with that. I'm not sure about color though, because I haven't really tried that, but I think it should be able to, yeah.
Awesome. We have time for one more question, one or two more questions. Are there anybody who wants to ask me? Yeah, Caleb.
Yeah, I have a question. Um, Sorry, like two parts. For the language, can it do any language, or is there like a specific set options that you have?
So I think I could make it do any language, but as of right now, I only have it set to Korean and Latin, but the Latin one doesn't really work because I kind of messed the code up. But yeah, I think
Oh,
I could
awesome.
just code it to do any language.
Super cool. And are there any other features that you would want to add on, like that are similar to that?
Oh, for like my speech to text or like
Or just in
my,
general?
yeah, so I'd probably want to make the optical character recognition use like a button instead of having to run on my computer all the time. So yeah.
Cool. Thanks for answering that.
All right. If we have no more questions, I will thank Charles for giving us that presentation. And we'll have Kayla kind of introduce our last student.
All right, thank you, Daniel. Yes, so our next student is actually joining us from the in-person program, but was not able to present at that demo night and was really eager to still be able to share his project with all of you. So he's here tonight to share what he worked on. And he was a very ambitious student as part of the in-person program. He actually did a project that was student-defined project. So he came up with this. And for those projects, we really ask that they come in with a lot of ideas and a lot of plan in place so that we ensure that it's something that can be achieved. And every time he just kept wanting to do more and more and keep innovating on it. And I think that it turned out really well. So I will let him take it away and share with you what he came up with. This is Vikram.
Give me a second so I can share my audio properly. This will take some time. Okay, there we go. Share. It should. Can you guys see my screen?
Yep.
Okay. That is great. All right. Let me. You'll start by seeing me in my webcam. Hello, my name is Vikram. I am going to 10th grade, and this is my project, the Marble Music Machine. I'll give a quick rundown of how this works and then show you some video clips from when my soldering underneath didn't quite fall apart yet. So down below here, you'll see a giant keyboard with a bunch of buttons. And this lets you record whatever notes you want to play. So you can play these buttons in whatever order you want. And the goal of this is to replay the notes you press. Once you finish recording here, the button presses will get sent over to the Arduino, which will then replay the exact button presses with the servos above. The servos, once activated, will drop a marble down this chute and onto the keyboard, which will play a sound. And of course, having to clean up a bunch of marbles isn't a lot of fun, so I built this conveyor belt, which brings the marbles back to the top of the conveyor belt to be redistributed. So if you press this button, you can actually play music forever and not have to clean up any marbles. Now, let me show you a quick video on the screen presentation of me actually playing the buttons. So I'm just playing a quick scale and then press the start button. Now, each of the servos has to be calibrated. So you can see that during the video, it hasn't quite been working out, but I have calibrated more of them. So more of them are working now. So this is a quick jump to the conveyor belt. It does move quite slowly, but I am planning on adding more buckets so it will be able to handle more marbles. And of course, once it heads to the top of the lift, it will go up here to this mechanism, which will spread the marbles out along multiple channels. So actually, I do have the original model right here on the side. And the point of this was to just randomize where the marbles went. So if you look closely, you can see a bunch of like random hot glue marks. You can see the paper here. And based on whatever speed the marble was coming in at, it would just make it go in a different spot with the hopes of making sure no marble chamber actually went empty. And that worked quite well, but there still was quite a big difference in where the marbles went. So I actually did create, give me a second, the mechanism up top. My cable is stuck, but the mechanism on top, which essentially works by taking one stream of marble, separating it into two, and then separating it into four, and then separating it into eight, and then 16. So it is very brute force like, but it does make sure that every single marble gets to go to the place where it needs to go. Some challenges I ran into during this were I had to do a lot of soldering because not a lot of the wires were long enough for my work. Power delivery was also challenging with a bunch of buttons, a bunch of servos, and also a mini display. And in addition, making this conveyor belt was a lot more challenging than I thought it was. It looks like it's just a belt system, but you really have to think about the exact tensioning of it as well. I chose this SDB because I wanted to do something that combined electrical and mechanical all together. And I just thought that this would be the best way to go. So that is my project, the Marble Music Machine. And does anyone have any questions?
Cool. I don't think we see the video. It's not moving, the sharing screen.
Yes, I stopped sharing the screen.
So can you just show the clip of the video again, Vikram?
Sure. Let me just share the content only, just so. Was it not moving during my presentation? Here.
It was
So,
like a little black box.
okay. Can you see it now?
Yep, you're good.
Okay. Now, as you can see, it did. Yeah. Did that work that time?
Yep.
Cool.
Okay, and then do you want to show the conveyor belt as well?
Yes. Oh, I should have. Let me head over here. Moving up. It's quite loud, but it does the job. So yeah, that's the conveyor belt. Let me switch my camera so you can see me. Okay. All right. Yeah.
All right, awesome. Thanks for showing us that. Okay. Yeah, does anybody have any other questions?
Yeah. So was your project mostly like hardware based, or did you use like any other like did you use any code to like make it run?
It was about 50-50. I think I spent half my time on code and half my time on hardware. Towards the beginning, I had to store the button inputs and then replay them. And I think during the storing and the replaying, that was really the most challenging bit because you can't use the delay function, which stops everything. So instead, I used the millis function, and that was something new that I had to learn. So that took a long time. And then, of course, I have slightly different modes on my controller. So I had to use different states of the microcontroller to figure out how those. So that took about a week or so. And yeah.
I have a question. So when you said you have to do a lot of soldering, what does that mean? I don't really know. I don't really know.
Oh,
Oh no, where'd he go?
looks like
Did we lose him?
I think we did. Yeah, he's not in the Zoom anymore. I don't know what happened. He was mentioning getting his computer charger, so maybe his computer died. But oh, there he is. He's back.
Hopefully he'll join us real soon.
Yes. There we go. Okay. Ria, can you repeat your question for Vikram?
Sorry. When you said that you did a lot of soldering, what does that mean?
So soldering is when you join two pieces of wire together. You can think of it like welding almost, but it's a lot smaller. But like the actual piece you use for soldering is like a pencil size. So I had to join a lot of shorter wires together to make one really long wire that would reach all of my servos. So that, yeah, so I had to do a lot of that, which is, yeah.
So I think we have time for one more question if anybody has.
Yeah, I have a question. How does your conveyor belt work? Like, is it based on like the weight, or do you like press a button and then it brings the marbles back up?
Well, let me move back into the garage. Sorry, my computer went out of battery. So there's it just turns on all the time. You can see I have a servo here. It just spins continuously when I turn it on. And then this servo connects to this axle, which is connected to the actual belt. So I just set it to spin continuously and it just keeps picking up marbles as they come.
All right. Okay, actually, if anybody has a question, we could probably do one more. Oh. All right. Well, great job, Vikram. Thank you for showing us that presentation. All right, so that concludes all the presentations that we have for you tonight. Just to wrap up really quickly, I wanted to give a big, big round of applause to all the students for sharing all of their amazing hard work. They really did so much in such a short period of time, and I'm so impressed and so proud of all of them. And we do have one more day of the program, so I'll see you all tomorrow. But for the stakeholders that are here joining us, just remember to please keep in touch. We want to keep in touch with you and the students going forward. Our support and our relationship does not end here. We frequently talk to students about recommendation letters in the future, about coming back to the program, coming back to work for the program. A lot of our instructors are previous students, so we do really want to keep in touch, and hope that you would like to as well. And so I'm going to go ahead and close out the breakout room so we can return to the main room, or if you have to head out, head out. But I'll stick around.